digital oscilloscope, and here you can see that there are number of knobs are there. This is a channel number 1, this is a channel number 2, and these are the voltage division knob, voltage changing the voltage divisions knob. These two are the for voltage division. This is for channel number 1, this is the channel number 2, and this is the common for both the channels, and this is the time division, second part divisions. Now I'll show you that I switch on that. I just switch on that. After switching on, you can see that that this is the screen. You can see that press any key to enter the system. I'll press any key. I press it, that F2, that it will enter the system. After entering to the system, you can see the one is a red line and one other is a yellow line. These are the indicating the channels waveforms at their present. Now I'll connect a probe into the channel number 1. I just connected channel number 1. I connected a probe here, and after connecting the probe, you can see your oscilloscope is properly set or not. That is a very important thing. You should see that before every experiment to conduct, that should be done. I connect this red one to this upper projections. After the connecting, you can see I am getting it a square waveforms. I'm getting. And another things, you can see that in the below it is written as CH1, that channel number 2, which is channel number, and CH2, channel number 2, and here it is written as 250 microsecond. Therefore, this is meant for channel number 1. It's in the sidewise it is written 2.00 voltage. Means that for channel number 1, what I have connected now, this vertically one division is 2 volt. Why the division? You can see the dotted lines here. You can see one dotted line here, one dotted line here, another dotted line here. In this, between this distance is one divisions, and that one division is equal to 2 volt. For channel number 2 also it is showing 2 volt, and there are, for time division it is common for both the channel, and time division is the horizontally. If you see one division horizontally, it is 250 microsecond. Therefore, in this particular waveform, whatever I got it now, you can see peak to peak, it is almost 1 division, 2 division, and 2.5 division. Therefore, 2 into 2.5 multiplied by 2, it will give you the 5. That means peak to peak, this waveform peak to peak is 5 volt. And if you come to the horizontally, you can move, you can position it. You can these ups and downs you can position. This is the channel number 2. The ups and downs you can position. Even in this you can position it in the horizontally, and you just make it coincide with this. After that you can see that one negative cycle is 2. Negative cycle is 2 division, and positive cycle is 2 division. Therefore, in one cycle there are totally 4 divisions in one cycle. Therefore, your time period will be 250 microsecond multiplied by 4, and that means this is the time period. And this, if you multiply 250 microsecond multiplied by 4, it comes to be 1000 microsecond, that is 1 millisecond. Therefore, and then you can find the frequency, that f equal to reciprocal of time period, and you can get 1000 hertz, that means 1 kilohertz. Therefore, we are this waveform having a frequency of 1 kilohertz, and vertically you have 5 volts. Peak to peak you have a 5 volt. Therefore, you can, this waveform peak to peak is a 5 volt and of 1 kilohertz frequency. Now this is about whatever I explained about the graph, whatever is displayed here. But now I am showing you some of the knobs. You can, in this knob, this is a channel number 1 I have connected. You can change the its shape vertically. Only it will change the vertical shapes. Therefore, it is the changing the vertical shape. and here you can see it is not very stable. It is not, the waveform is not shown very clearly. In this case, you can stop it. You can stop it, and then you can see, and you can, and here you can adjust it with the exact, and then now you can see there is only one division. Your vertical is only one division is the vertical, but here you can see the channel number 1 is changing to 5 volt, changes to 5 volt. Therefore, one division is equal to 5 volt. Therefore, the shape has been changed, vertical shape has been changed, but the measure remained the same. There now one division is equal to 5 volt. It is showing in the bottom. And time division, you can see the time division, but channel number 2 it remained the same. And channel number 1 it has been changed to 5 volt, one division. Channel number 2 it remained the same as 2 volt, and the time division also remained the same. Now I am coming to this. You can time division knob, you can change it. You can see it become a bigger one. Now you can see, now you can position it properly. You can see that here it is one negative cycle, 1, 2, 3, 4, 5, one negative, and total is one cycle. There are 10 division, but here the time division changed to 100 microsecond. That 100 microsecond into 10, again it is a 1000 microsecond, one millisecond, and your frequency is 1 kilohertz. Therefore, the shape will change, but the measure will remain the same. Now I am coming to the few of the knob. Here already I told you that this is the shape, vertical shape of the waveform will change vertically by this knob, and it is only for a channel number 1, and this is for channel number 2, and that vertical shape will change. This for channel number 2, and this is for time division, second part division. It is for both, it is together both, and this is the positioning. Is can ups and down, you can do the positioning. And for the channel number, this is for channel number 1, and this for channel number 2, and this is horizontal positioning you can do. And another thing, important thing, suppose you want to use the channel number 2, you just again you connect it, and you should also, before any type of experiment, you should see that this is properly set. Now here I just, this is, you can see this is a not very stable. Again you can make it with the stop and run and stop, you can make it stable, and then this the square waveform is coming. Before you get in the square waveform, both the channels, what if you use the both the channels, you should get the square waveform by connecting the red one to the upper projection. If you do not get it, don't start your experiment, because your oscilloscope is not properly set till. In that case, what you do, if it is not properly set, you can see there are two buttons are there, auto set and auto scale. And this will bring, these two knobs will bring the oscilloscope into a default. It will bring it to a default. Then if you do not getting, you press and bring your oscilloscope into all the default parameters it will take. Another thing important, suppose you want to off that, you want to off the channel number 2. You press in the channel number 2, you can see it is appearing channel number 2 setup. The first one, DC coupling, the F1 is associated with this, then F2 is associated switch off and on, then F3 is associated with the probes, and you want to get the inverted waveforms, or if it is off you will not get inverted waveform. Now I want to make it off, channel number 2, that is, now it is on, I press F2, it will become off. You can see that it has become off now, and this is whatever the necessary knobs and necessary setup we require for digital oscilloscope that I just explained.